What is a function? Combination of numbers and letters, all right. A function, let's view it this way. A function is it's just an equation, okay? But it is a yes, okay? So it is any equation in which we've already solved for y, okay? And every x value has one and only one y value. So let me show you something here. All right, so let's just hide that one real quick. We'll hide that. If I type in like the square root of x, which we've been working on, square root of x, that's a function because no matter what x value I tell you, to look at, so let's say we want to look at x equals 4, okay? So I'm just going to draw some lines here to see, to draw our attention to it. So let's go there, and now let's just draw let's see the intersection there. And we'll go parallel to that. All right, so if I were to look at and ask you guys, look at x being 4, okay, and we draw a line straight up, a vertical line up through 4, and it intersects my blue curve, okay, and then look over what is the y value that I get. Does it show that at 4, the y value I get is 2, correct? Okay. So when I ask that, what is, the way we write it is if this is f of x, if this is f of x equals the square root of x, and I ask you what is f of 4, so I'm telling you, look at the 4, okay, see what that gives you back here on the y-axis, we would say that it is essentially radical 4, or it gives back 2, right? So f of 4 gives me 2. We talked about this being the input. This is the output, okay? Ultimately, okay, that's your x value. That value of 4 is your x value. This 2 is your y value, okay? But this notation that we've used, f of x, we've written that f of x equals y. Would you agree with that? If I make the argument that we went from that right there down to that, okay, f of 4 equals 2. F of 4 equals 2. Is 2 the y value? Make sense? So f of whatever, f of x, is a y value. So every one of these that we see, if I say f of x equals radical x, okay, I am telling you that that is really y equals radical x. It's an equation in 2 variables, but instead of using y, I use the notation f of x to tell you that it's a special equation, to tell you that when I look at a group of people, when I say everybody tell me what is the y that goes with 4, everybody's telling me 2. Does that make sense? Okay. That is different than some equations. Because some equations might look like this. There might be an equation that says okay, that's an equation. It's x equals y squared. Now, if I ask everybody to look at the x value of 4, so we're all looking over here at x value of 4, which should be right here, correct? And I asked you, what is the y value that goes with 4? Would some people say 2? Does that make sense? So if I look down here, would some people make the argument that the y value that goes with 4 is -2? And those are different values, right? Okay? So in that situation, this is not a function. You guys remember talking about the vertical line test? The vertical line test just tells us, it's a quick way of checking, when I ask a question, look at x and tell me the y value that goes with it, is there one and only one y value that's going to get back? Is everybody going to tell me the same y value? Okay? So a function, right now, the way I want you guys to view it, is that it is an equation, and there's only going to be, when I ask you to plug a value in, there's only going to be one y value that you get out. Your neighbor is never going to get something different if you both do the right arithmetic. Okay? That y'all remember a little bit with functions? Okay? What we're going to do in the next couple days is operations on functions. Okay? Now, an operation on a function, you guys remember what your operations are? If I use that terminology. Okay, multiplication is one. Okay, so your operations are adding, subtracting, multiplying, dividing, right? So what we're going to do is we're going to take our functions and we're going to add them, we're going to subtract them, we're going to multiply them, we're going to divide them. And we're going to do it in multiple formats, okay? If we look here, it says two functions, f and g, okay, are combined to form new functions, f plus g, f minus g, f times g, f divided by g, and we can also do g divided by f, in a manner similar to the way that we add, subtract, multiply, divide real numbers. Okay? So, what this says, it says, for example, we define the function f plus g this way. Okay? So, if I tell you something like, let's just say we have a function f of x equals x. Okay? So essentially that's the line y equals x. Does that make sense? And I give you another one that says g of x, let's say, is equal to, let's just say, 3. So there we've got the line y equals 3. If I asked you to find f plus g of x, which is what this is saying right here, that is identical to you taking whatever f of x is and adding to it whatever g of x is. So if I did that, what is f of x? It was x, right? What is g of x? We're saying it's 3. So in this case, if I add those two things together, f of x plus g of x, it gives me x plus 3. Okay? Now, we've graphed x plus 3 before, correct? We've graphed lines. We've come across every equation we've come across so far through all of our math courses. If there was a plus sign, a minus sign, a division sign, or multiplication in it, it has been a combination of simpler functions. So x plus 3 is already, like I said, we know how to graph that. Y-intercept of 3, rise and run of 1 over 1. We know how to graph that. But it is the sum of these two simpler things. Okay? So I'm going to show you what we mean by that. So I'll go to Geogebra here. Let's do this one here. Well, what happened? So here I've just got this set up to where I can type in the two functions that I'm interested in, okay? So I'm going to type in here, we just want x. So there's x, and then I want to type in 3, and there's y equals 3. Okay, does that make sense to everybody? Okay. So what's going to happen here, what we're trying to do, okay, if I were to come down here at an x value of 0, okay, it is asking you, when we do f of x plus g of x, and f of x was x and g of x was 3, and I ask you to add those together, what we would be doing is adding the y values from this and the y values to that, okay? So when x is 0, the y value that I get back here would be 0. Does that make sense? Okay? So I'm going to plot some points here to see if we can make a connection between what's happening with this information. So when x is 0, okay, I'm going to add ultimately this purple segment, and let's see here, if I go over here, you guys see that? Can you see that dotted segment right there? Let me see if I can make that bigger. It's kind of nicer on my screen than yours. It's the blue one. All right, is that okay? Can we still see that the whole purple one would be all the way from the x-axis up to here? And then the blue dotted one is this one, right? Okay. Basically what we're doing here, when I get to x being 0, that blue dot line becomes a length of 0, right? So basically what I want to do is I want to add the blue dotted line's length and the pink line's length. So if I add those together, what do I get? Yep. I get 3, right? Okay, so I'll plot the point 0, 3. So when x was 0, the sum of those two distances became 3. Okay? Let's move this thing out. Let's make x go to 1. Okay? Now, if x is at 1, okay, let's take that blue dotted distance, which is 1, right, and add it now to the pink distance. So what would that give me? 4, right? So when x is 1, that sum is 4. Okay? Let's make this 2. When it's 2, how big is that dotted line? 2. And how big is the purple one? 3. So what's 2 plus 3? 5. So when x is 2, the y value is 5. Okay. Let's make this x value, let's go to 3. We'll do 3. Okay. Now they're both, the blue one's 3 and the pink one's 3, right? So when x is 3, the sum is 6. When x is 4, okay, now the blue one's the bigger one. So now the blue one is a height of 4, right? And the pink one is a height of 3. So 4 plus 3, 7. So when x is 4, y is 7. Okay? Now, we've done enough here. I think you can see that as I move this direction, is that pattern, is that rise or run going to be the same each time? Okay? Let's go this direction. Let's say, what if x was -1? Okay? Now what we're going to do is we would be subtracting. Okay? So if I were to take, so let's take the pink one because that's a positive distance because it's above the x-axis, and this dotted one is a negative distance because it's below. So this dotted one is a length of -1, and this one here is a length of 3. So what's that give me? Gives me 2. So -1, comma 2. Is that point in line then with these other ones? Okay. So what we're generating here then, okay, if I were to take, so f was x, g was 3, if I take those two things and add them together, does it give me the line that passes through all those points that we just created? That makes sense, everybody? So when you write an equation, no matter what equation I give you, okay, so let's just come over to the side real quick and write one that we've seen from the past. Let's say that we have f of x equals x squared plus 2x plus 3. Well, what that means is that we're actually looking at, and I'll just use some different letters. I'll use h of x is x squared. Let's say g of x is 2x, and let's say k of x would be 3. This is really adding all of those things together. Does that make sense? Okay. In this one here, would actually be saying if I've got g of x is equal to 2 times x, that could say that maybe I'll use a of x was 2 and b of x is x. And instead of adding, I'd now be multiplying a and b. Does that make sense? Okay. So what we're getting at here is that when we're dealing with functions, they may be complex looking things. And it might be hard to work with as a complex looking function, but you can always work backwards and break it down into smaller things and work with those smaller components. Does that make sense? Or if need be, if you start with a smaller one and want to build something more complex, you can do that through addition, subtraction, multiplication, division. Okay. So the new function f plus g is called the sum of the functions. And its value at x is f of x plus g of x. That's what we just talked about. It says, of course, the sum on the right-hand side makes sense only if both f of x and g of x are defined. That is, if x belongs to the domain of f and to the domain of g. What that is saying right there, let's say that I have f of x equal, you guys remember what domains are? Let's say f of x is equal to 2x. Okay. The domain is all valid input values. And what I mean by valid, it means that they give a defined output. Okay? Essentially, it's all the x values that you can use in your function. Okay? And what I mean by that, if I choose a number like 0, okay? When I plug 0 in for x, can I take 2 times 0? You allowed to do that algebra? And that gives you an output, right? It gives you 0 back. Okay? Can I choose x to be 1 and take 2 times 1? Do you guys all know what 2 times 1 is? Yeah, and we're getting an output back, right? If I plug in x to be a half, 2 times a half is 1. I get an output, okay? No matter what number I choose, so let's do this in Desmos, okay? If I say f, I'll have to write it this way. Let's go. Let's just say 2a, okay? I can't use x because it'll start graphing over here, but that is my variable x that I was talking about in the notes. The a value, I'm allowed to slide this around, and what it's going to do is it's going to evaluate 2 times 0.6. It's going to evaluate 2 times 2 times 2.9 gives me 5.8, right? Every number I choose, now this goes from -10 to +10, and it does it by, it keeps moving by tenths, but I can change that. We want to edit this. We want to make the step 0.001 or something like that. Okay, we can put any numbers in here that we want, and that didn't do anything. I don't know why, like, it gives me that step. When I say step here, it should change this from 2 point, like 2, 0 to 2.21, 2.22. For whatever reason, it's not doing that. But no matter what I put in here, is this a number that I'm getting back? Yeah, okay. If I were to graph it, the domain is the list of all x values that you have on this graph. Does that make sense? Okay. So, there's a point on here in 5, 10. So x being 5 is a domain value. Okay. There's a point on here 4, 8. There is a domain value of 4 then. Okay. Everywhere on here there is a x value that you can use. So the domain for this one would be all real numbers. Okay. All real numbers. There are some, though, that we can't do that with. Think about the ones that we've just dealt with recently, square roots. If I say radical x, okay, and I look on Desmos for radical x, so again, I have to use a instead of x. So if I go square root of a, okay, you see that when a is 0, I get a number back. When a is positive, I'm getting numbers back, right? Because, for instance, when a is 4, remember what this means, it's what number multiplied by itself will give me 4. Well, 2 does that. But if I choose a negative number, you see how it's not giving me anything back? It's saying undefined. It does not exist. Because the idea is now, okay, well, what number do you multiply by itself 2 times to get something that is negative? And no matter what you choose, 2 times 2 is positive. If it's got to be the same thing, then it means I could choose negative 2 times negative 2, but what's negative 2 times negative 2? Still positive, right? So there's no way through multiplication to multiply something by itself twice and get a negative number. So this is undefined for negative numbers, meaning that when we graph this, when I look at the square root of x, it looks like this, okay? And I start listing the ordered pairs that are on this. Will I ever list an ordered pair that has an x value that is negative? Is negative 2 ever an x value on this graph? No, okay? So the domain there for that particular problem, that particular function, would be values that are bigger than or equal to 0. This one, the domain was all real numbers, okay? And this one here is bigger than or equal to 0. So here's my question, and this is what the previous statement was getting at. If I ask you what f of x plus g of x look like, you would write that, take f of x, and add to it g of x. Is that okay with everybody? Okay. That function, if I ask you find f of, let's just go 4 plus g of 4. Well, that means I'm going to take this thing here, and wherever I see the x's, I'm going to put 4 in, right? So I'd have 2 times 4 plus square root of 4. What's 2 times 4? 8. What's square root of 4? 2. So it'd give me 10, right? Okay. So let's see if that makes sense visually. Going back over here, so we had f of x was 2x. Let's say g of x is square root of x. Okay. And now I want x to be 4. Go out there. Okay. We're getting a height here of 2 for that purple line. We're getting a height here. Okay. I want to get rid of this red line. That's not the one we want. I'm looking at a height here of this dotted blue one of being 8. Okay. And then if I look at 2x plus the square root of x, what that graph looks like, that graph looks like this orange-looking graph right there, but is the point 2, 10 on that? Does that kind of make sense? Okay. So f of 4 plus g of 4 is 10 in this situation. But what if I ask this? Find f of negative 2 plus g of negative 2. You would now plug negative 2 in there, right? So I have 2 times negative 2. And you plug negative 2 in here. And that right there is a problem, right? Okay? Because it's undefined. So that is a number that the best way I can say is that it doesn't exist. There is no such number that I can take the square root of and get negative 2. Or that I can multiply by itself and get twice and get negative 2. So when I asked this, I asked, okay, well, what is the sum then of negative 4 plus a number that you don't know? Can you tell me what that sum is? I'm thinking of a number right now in my head. What is the sum of negative 4 in that number? You don't know, right? Because you do not have that number in my head defined for you. You don't know what it is. So you can't do that sum. Does that make sense? Okay. So if I were to ask you over here, we'll go back to this. Let's choose x to be negative 2. Okay, remember what we're doing here when we're looking at these, when x was positive, we would have a blue distance and a purple distance, right? Do I have a purple distance there? So I can't add the blue distance and purple distance together and get a sum because I don't have a purple distance. Does that make sense, everybody? Okay. So functions, when we add them, subtract them, multiply them, divide them, all that kind of stuff, they are only defined where both individual functions, smaller functions, are defined. Okay. That's what this phrase right here is targeting. It says if the domains of f is A and the domain of G is B, okay, then the domain of f plus G is the intersection of these domains. Okay, what is that saying? Okay, so when we use a capital letter like this, like A, it's saying that my domain is the set of numbers that we're calling A. So for the problem that we did, if I say, we said f of x was equal to 2x. The domain of that was all real numbers. Okay, so domain of that, a couple of different ways you can write that. All real numbers like that, or we can write it in what we call interval notation, negative infinity to positive infinity. You can choose any number you ever want. Does that make sense? If I look at it as a number line, let's put 0 there, negative infinity there, positive infinity there, and the way we've always graphed number lines is that we would kind of shade on top, right? Okay, so that's describing visually what my domain is, and this statement is calling that capital A. Okay, so that graph that I just drew, or that interval right here, that list of numbers is what they're calling capital A. Okay, if we look at the other one that we wrote, we said g of x was equal to square root of x. That domain, we said, was x has to be bigger than or equal to 0. So in interval notation, it would look like that. But if I'm talking about a graph, there's 0, here's infinity. That's what I would graph, right? So this red graph up here is A. This lower graph is B. The domain then for 2x plus radical x, the domain of the sum of these two functions, is where those red graphs overlap. Where do those red graphs overlap? Where do they start sharing same values? Start at 0, right? And they keep overlapping all the way to the right, correct? Okay. So when I ask what is the domain of f plus g of x, even if I don't even want to, so f plus g of x looks like 2x plus square root of x. If I want to know the domain, it is where these two things overlap. So I say domain, they overlap 0 to infinity. Okay? And what's nice then is once I find that, for adding them, if I subtract them, same domain. Multiply them, same domain. Divide them, same domain. There's a little bit of a a caveat with dividing. We'll talk about that tomorrow, or I guess Monday. But no matter what you do with your functions, this is the algebra rules for functions. Okay, but adding, subtracting, multiplying, dividing. And I know it looks kind of messy, but it's just notation. It says if you're going to add to, if I ask you what f plus g of x is, that's simply taking what f of x was and adding to it what g of x was. If you want to subtract them, it's the same thing, but you subtract them. You go f of x minus g of x. Okay? And you see over here it tells you the domain. Okay? This is the mathematical way of saying overlap or intersection. Okay, that symbol right there is actually what we call an intersection statement. Okay, but you see that the domain, no matter what f and g were, no matter what I do with them over here, domain is A intersect B, domain is A intersect B, domain is A intersect B. So the domain is always overlapping. So what I mean by that, if, let's say we had this here, okay, so let's talk about these two functions again. Let me hide some stuff. Let's get rid of this thing. Let's get rid of these points. Okay. I'm going to ask what f plus g looks like. And might make more sense maybe to put the sum in the blue here. So these are the two individual smaller ones that I want to add together. The green one and the red one. And I'm going to put their sum over here in the blue graph. So I go f plus g. So this is the sum. This here is 2x plus radical x. That's what that graph looks like. Do you see that it's not graphed over here when x is negative? Because if I overlap the x values for these two, the overlap of x values for these two are only the ones from 0 to infinity, right? So then for this, the domain is only 0 to infinity. Let's take, so that was f plus g. Let's go f minus g. Let's go f minus g. It's that graph now. A little bit different. You see this little weird little dip here at the origin. But you see the domain, it's still just the overlap of the x's for that one and the x's for that one. Okay, let's go f times g. So that graph's going to look like that. So f times g, you still see the domain is still just these values from 0 to positive infinity. Is that okay with everybody? Okay. If we do, let's say that instead of square root of x, let's go square root of x plus 5. So now it moves this graph over to negative 5, right? So x values now will not be, I don't see any x values, so it's red curve to the left of negative 5. So then when I go f plus g, you see that thing stops at negative 5. You don't have any x values to the left of it. Does that make sense? Okay. If I go f times g. Oh, let's go over here. That's kind of a weird looking graph. F times g. Okay. You see that to the left of negative 5, you don't have any values, any points plotted, because over here, that graph and that graph only intersect, they only overlap to the right of negative 5 and not to the left of it. Does that kind of make sense about domains? Okay, and how we, because what's going to happen, and what I worry about is, I'm not worried about you guys being able to say, okay, if I give you, let's just say I give you f of x is equal to x squared. Let's say g of x is equal to x squared plus 3x. And let's say h of x is equal to x cubed minus x. If I asked you guys to find f of x plus g of x plus h of x, I'm not worried about you taking, okay, well, f of x is x squared. Add to it g of x, which is x squared plus 3x, and then add to it h of x, which is x cubed minus x. And then rewrite, they'll ask you to simplify it, so you'll have to write it in descending order. So x cubed, you guys see that we have, what those are going to give me 2x. And I'll have another 2x squared, so I'll write it this way. I'm not worried about you guys being able to come up with that. And that's what part of Math Excel will ask, is what is the sum of these 2 or 3 or 4 functions. But the next part of that question will say, what is now the domain of that new function? Okay? Well, it's the overlap of all of those domains of f, g, and h. So I want to make sure that we understand how to do that. I don't want to give you guys 10 questions, 1 point each, and you should be able to get 10 out of 10, but you only get 5 out of 10 because you don't understand how they're asking that domain stuff. Okay? So that's what that's all about. We'll reiterate quite a bit of that on Monday. Keep that packet. That packet is, we're going to talk about that for several days. Okay? Probably all the way through next week. Okay? So hang on to that. And tomorrow, short, write 5-question quiz over radical equations. No homework tonight.